Welcome, this is Skip Jeffries, skipjeffries.com. Just a quick video here. Main objective of this video is just doing a quick down and dirty print of a doorstop. Earlier, back in January, I had to do a wall repair. We have this door going into our garage. That doorstop itself was placed as high as it can go on the trim, and you don't really want to place a doorstop on your drywall because all it's going to do is bust through anyways. But this thing has been a never-ending battle with me. I'd go ahead and patch a wall, and a couple weeks later, either somebody will open up the door too hard or the wind would catch it. If we had the back door open, it'd be almost like a suction vortex that slammed the door against the wall, and the doorstop sits at a funky position. There, let me pull this one off here. Guys! Where the doorstop actually slides underneath the door itself, causing your door to hit the plate. I added a bump rest against the wall just to help protect it, but when I was doing the repair, I went ahead and just quickly fabbed this thick part. I was thinking I wanted to make sure that door would not slam into the wall, and I didn't want to repair this wall again. So it's ugly, it doesn't look good. I'm coming up with something that's a little bit slimmer, a little bit trimmer, look nice and kind of hide if it will. I mean, I'm printing it in white PLA, so we'll see how it goes. We're gonna do a quick in dirty 3D print. Got a part I need to create real quick for the house here. I've got a door stop that just doesn't want to fit right, so I'm gonna pop into FreeCAD here. Start with the XY plane. I mean, you can literally start in any plane that you want, but I usually, XY seems to be my plane of choice. Or start with just a simple circle drawing. What I'm creating is a door stop. I've got one that I put on there temporarily when I was doing the repairs. And I wanted something that looks a little bit nicer. The one I've got on there was just, like I said, real quick and dirty. Just wanted something to keep the door from slamming into the wall. The doorstop that we currently have on it wasn't doing its job. It was just missing the edge of the door ledge bottom, and it would catch every now and then when the wind would hit the door, or if somebody opened up the door too hard, the door would actually slip under, or the doorstop would slip under the ledge and ran right into the wall, creating a hole. I don't know how many times I've passed that hole, but I'm going to create a more permanent, better looking type design here. So I'm going to start with a simple circle. We're going to go ahead and set our dimensionals on that. I like to do constraint radius. Just click on your circle. I'm going to set that to about 24. Most of the stuff that I do on FreeCAD, I kind of do a hardcore drawing, and this is just based on it. So we're going to go ahead. It's fully constrained by the green fully constrained that you can see over here if you see my cursor. We're going to go ahead and hit close, and this is the tab out or pad out button. We're going to pad this thing out. Normally it kicks out to 10. It looks a little thick. I want a little bit thinner profile, so I'm going to kick it down to 5. Looks pretty good. Go ahead and hit OK. Now we're going to add on, I want kind of a conical shape on there, so easiest way to do it is just kind of click on the edge that you want to attach it to, go to your add additive, and we're going to select additive cone. And you can see it here on the picture here. We're going to want it on that XY plane. I like to double check to make sure it's looking like it's attached there, and it looks like it's going to be pretty good. We're going to want it to go the other way, but that's no big deal here. We can easily fix that. You got your radius 1. The easiest way to tell the difference is click on one and see which one expands out. So the radius 1 is the bottom one near the part there. So we're going to try to kick this thing out to about maybe 20. I like that. The radius of my inner hole to fit over my doorstop is 7, so I want at least the radius, outer radius of that to be probably at least a 10. Give me a little bit of thickness and girth around it. I mean, you could possibly go up to maybe a 12, 15. I mean, it's whatever your heart desires. So I went with the 5 there, so I'm going to kick the height up to probably about 15 millimeters. And like I said before on my previous video, I like to do everything in millimeters. You don't have to, but to me it just makes sense and it's pretty easy. Now the next thing I want to do is just see where that cone lies within the part, and it looks like it's falling right on that top portion there, so that landed pretty good. So we're going to go ahead and okay that, and there you go, you got your conical on there. Now we're going to create our, they call it like a detractive additive here, and that's noted in the red here. We're going to select a subtractive cylinder, and our radius we're going to go with the 7, because that's what I used on the temporary one. And we're probably going to go down 15 millimeters of a hole. Let's see where that, there it goes. So we're going to need to push that one up because we want the hole on this end here. And the easiest way I found to do that is to find out what axis runs north and south on your picture of the direction that you want it to go. So it's the Z axis here. We click the slide bar down and go to our Z direction. We're going to bring that additive up. Why is it not working here? It should bring it up. There it goes. Now, scratch that. We'll bring the additive down in the Z direction, and we'll put that sucker flush to that top surface there. And it looks like we got a little bit over that. It should be down about 15. Looks pretty flush. Like I said, the easiest way to tell is just kind of flip that sucker around and do a 360 view on it. It looks pretty good, and just to make sure it doesn't come out the other side. That should give us at least a 5 millimeter depth at the end there as a stopper. And we're going to slide bar up, hit your OK, and there's your basic door stop shape. So we got some kind of hard edges here. I'm going to add some tapers on that. Let's see if we can get that added to it and not screw this thing up. And we're going to let's add a fillet on the edge of that. Let's go 2. We'll do the same with the other. That's 2 select. Let's see if that'll, we'll go that to 2 too, so it'll round it out, kind of giving you a pretty good profile here. And that looks pretty good. Now it's this top edge, you could probably do a radius on that to even it out, but it's going to be flush against the door stop, so I mean, realistically, we'll see what it'll look like. We can maybe add another edge on there if we want, but I'm going to leave it as is. Looks pretty good. We're going to go ahead and hit OK. And then to get this thing ready to print, you want to make sure the entire object is highlighted. So I mean, you can go in and actually name the body if you want to. Rename, you can call it doorstop. V2. And then, like I said, you want to make sure it's highlighted, all in blue here. And then go in, click your file, hit your export, and it'll automatically kick it over. Since I've been doing mainly with the Bambu Labs, it kicks it out to the Bambu Lab format for actual print, and we'll go ahead and just click save. And so when we bring up, yeah, you want to save your changes in case you want to make changes to it later. I've got quite a few in here. We'll call this the door stop. Hit your save and that automatically saves it. Go ahead and open up Bambu Studios here. I'm going to add our project. Oops. Go to preview. Oh, come on. Add what we want to print. And it should automatically, let's go to our D drive, should be in my 3D objects. Date modify, there we go. And the key to this thing is just to where it lies on your print table here. You want to make sure you've got a good flat edge. You don't want it flipped around the other way because the angle of it will cause a lot of supports, and you don't want a whole lot of supports. All that does is waste your filament. So that looks pretty good. We're going to go ahead and slice this part, and you should get slice okay. And I also like to just run through the slice just to see how it looks, and it looks pretty good. I think it'll work for our function of creating a doorstop for us. So we're going to go ahead and print the plate. And yeah, A3. I want to change it to my A1, and we could just use PLA on this. It's going to be indoor anyways. Go ahead and send it. And the cool thing about this whole program here is you can get on-screen video as it's printed. Better light on there. Go ahead. And right now it's just running through the cooling process. I'm gonna probably hit pause and let this sucker run for a little bit, and then I'll click you on once the action starts going. Alrighty, getting this print party started here. What you're looking at now is just the initial first layer kind of systems check that goes on with these Bambu printers. Just making sure your first layer adheres, and it's doing just a kind of a self-test to evaluate how the print's going to turn out. So to me, it's awesome because it ensures your print starts off from the get-go going in the right direction. But there you see it, it's actually scanning the filament layer that it laid down there just to make sure it's an even coat and everything's adhered and there's nothing funky going on with it. I'll let this thing run for a little bit. I want to see how quick it kicks over, but this print here is relatively one of the quicker prints I've done in a while. It's only 20 minutes, so it should be quick and dirty. Hopefully it turns out. Normally these short ones usually do. If not, I mean, it's no big loss, not a whole lot of filament. We're talking, what, 9.44 grams, so quick and easy. I like this one. I mean, there it goes. It's starting to lay down the initial first layer of the doorstop itself. Like I said, this design was just kind of a revamped of what I had quick and dirty when I was doing the repair on the wall. Just wanted to make sure that door could not slam into the wall, causing some more damage. I mean, like I said, ever since we moved into this house, I've been repairing that wall almost on the monthly basis when you have kids in the house, because teenagers especially, a lot of times they don't give two craps when they open up the door coming home from school. Oops, I slammed the door, or they won't tell you, and you kind of know. It's a couple days later, it's like, what the heck happened to the door? And everybody shrugs, oh no. But anyways, hopefully this will resolve the problem. Hopefully it's thick enough to withstand the pressure. I mean, it doesn't have to be great or awesome, but I just want something that looks somewhat decent, that'll hold up to what we needed to hold up to. And it's basically one of the main reasons I wanted to buy a 3D printer is just to do this little rinky-dink stuff around the house. So I'm going to go ahead and right now you're seeing it's actually clearing out the filament, so it's going to start knocking out the layers here pretty quick. But I'll pop back in when we hit about 50%. As you can see here, we're sitting at about 50%, so I mean, relatively pretty quick print. I mean, finish time in about 17 minutes. Like I want to stress before, I mean, the whole reason I placed the part the way it is to reduce the amount of supports. I mean, Yeah, it's good to have supports when you actually need them. If you can avoid them, it's great because that's less cleanup work that you have to do on the part itself. To me, I like doing more of a angle on the going up surfaces of it because it creates a smoother finish. And then if you could have your print flat at the bottom, you get a pretty clean finish that actually with the texturing on the plate itself, it gives you a pretty cool looking finish on your prints. If you're into that uh, kind of contour that you like seeing on some parts, to me, I just kind of grew to like it. So I do what I can to keep the flattest part on the plate itself. But I'm gonna go ahead and just let this thing print out, and I'll probably check back in at about 75%. All right, we're sitting about 75%. As you can see, the part starting to take shape here. So far, it's looking pretty good. With this part being so small and quick and dirty, I didn't do any glue stick on it, so hopefully I'm not going to pay for it. It looks like it's adhering pretty good. Haven't had a part peel up yet on this thing, so we'll let her run, and I'll hit you at about 100% and let you get a final view of the ending of the print here. Yeah, all right, we're getting closer to this one to finish printing up. Like I said, it's a pretty quick print. I just want a caveat on it. I mean, don't let an AutoCAD program kind of hold you back from getting into 3D printing. I mean, to me, there's enough information on YouTube. There's a lot of instructional, educational stuff that you can look just to get the basic concepts, get you started, and just keep hammering with it. I mean, there's also a lot of other CAD programs out there a little bit easier. I think there's like 360 or Fusion 360, which is supposed to be about the user friendly. There's Tinkercad, I think, but there's a lot of programs out there. But man, I mean, even if you can't get into the 3D design part of it, there's plenty of prints on Thingiverse and all kinds of different websites that you can download and just print just about anything that you want. But just keep at it. I mean, the initial costs are kind of expensive, but it's worth it in the end.
Here's the proof in the print. Got a nice lower profile, so hopefully it hides a little bit better, but we'll go see and make sure it fits. Money. For anybody that's wondering where all the barking's coming from, I've got two Dachshund mixed dogs here. I've got Oreo here. He's a Australian Shepherd Dachshund mix. We got him from my son. He lived in an apartment, couldn't keep him anymore. He was working too many 12-hour shifts, and the dog was just getting stuck inside, so we went ahead and took him. And then we got our dog Charlie here. He's another Dachshund mix. He's a Dachshund Bulldog mix, so he's a little bit shorter and stockier. Kind of looks like a seal, but he's 10, Oreo 7. So I mean, you'll hear him in all my videos. It's hard to do any type of recordings with these guys around the house. So based on the cost formula sheet that I've created, this part here costed roughly about 85 cents to print. So I mean, proof is in the pudding. You can't buy that in the store. But anyways, thank you for watching.